I'm Cathy O'Neill. I'm a data scientist at Intent Media, and I'm here to talk to you about why you should hire all my friends. So I understand that not all of you are all that analytical minded, and I don't want to underestimate anybody. And I'm not typically giving talks to this audience, so I'm going to do my best. But I'm going to be here all day, so if there's anybody who has further questions, then absolutely come up and talk to me. And I apologize in advance if I'm not setting the right tone, and if you guys have questions during the talk, please also ask. So my first question I'm going to answer, hopefully to your satisfaction, is when do you need a data scientist? Well, the first sort of sign that you need a data scientist is, oh shit, I can't put all my data on Excel. How am I ever going to analyze it? How am I going to see into it? Next clue is you have experience in visualizing data, but there's a certain way you want to visualize it. Maybe you can't even make it well defined, but you don't know exactly how to do it in a satisfying way. That's one of the things that data scientists do, or should do. This is a really crucial issue that you might not even be aware of is a role that a data scientist can take on. But if you see noise, if you see data, let's say you see numbers coming in, and you don't know whether they're noise or signal, are they actionable or not, then you might have a data scientist help you analyze what the underlying message is. And finally, every estimate, any estimate you have, any number you see coming in on your spreadsheets, they're always estimates, right? Sometimes they're money, so that's not really an estimate. You actually know exactly how much money, how much revenue you made. But for the most part, it's an estimate of how you're doing in your business, and any estimate at all has error bars. And what is an error bar? Well, it's related to a confidence interval. It's a way of saying, okay, here's the best guess for this number, but what's the real range that it could be in? And if you have some idea of how to define that, that's one thing, but if you really have to have a pretty precise idea of how to define that and to understand it and to explain to other people. And that's, if you don't have all those things, it might be another piece of evidence that you could use a data scientist. That's what they do. But let's take a step back. Like maybe you don't even know you need a data scientist. Maybe you should need a data scientist. So what are ways where you could be missing that need when you shouldn't be? So in other words, are you asking the right questions? Maybe your business model isn't as quantitative as it could be. Now, if you had the right question, if you were asking the right question, which could be a harder question, then in that situation, you would need a data scientist. So this is a way you wouldn't actually need one right now, but you should be needing one, possibly. Second possibility. Are you getting the most out of your data? You might not think you need a data scientist, but you might be sitting on a lot of good data that a data scientist could use, could analyze, and could improve your business. And I'm going to talk about one example at the end as a case study of how you could use the data you already have in a way you hadn't thought of. Similarly, are you anticipating shocks to your business quantitatively? Like you certainly have to think about, well, what if I lose a client? Well, that's bad, but how bad? What if I get another client or this, and at the same time this happens? What if the tax changes come in this way? There's all sorts of things that are actually quantitative adjustments to your business that you only vaguely have a sense of how it would affect your bottom line. And that's something a data scientist can help you with as well. Finally, sort of a general question, are you running your business sufficiently quantitatively? Are you are you collecting the data you should be collecting? You might not need a data scientist because you might not have the data you should have. So there's another possibility. So now let's move on to the assumption that you've decided to get a data scientist. And I applaud this decision. What processes do you need in place for that to even make sense to hire someone? Well, you need, obviously, a way to store your data. And typically, if you have enough data, the kind of data we're talking about this week, that means you have perhaps data on the cloud or on a really serious set of computers. You need to get access to that data as well. Now, typically, there's a payoff. There's payoffs for various ways of getting access. I'm going to just assume for a moment that you have your data in a cloud. Then you could certainly do something that's relatively easy, but also relatively expensive, which is to get a database service that has SQL access. Why is this good? Well, it's easy, it's standard, and you can hire someone who, right off the bat, knows how to get that data. So it's kind of a no setup, no front-end way of data access. Another thing you could do, though, is you could look for a way of open source data access on the cloud. And those kinds of things do exist, but typically they're not standard, which means that the data scientists you hire or the tech people you hire that use that will have to invest their time into learning the system. So it's a question of how much time do you have versus how much money. Now, with really large-scale data, terabytes of data, you're collecting, so you should absolutely know how much data you are collecting, what the rate of data you're collecting is. If you're collecting terabytes of data over the months, then, and depending on what the format of your data is, you might need a different kind of access to your data, which we call Hadoop. This is something that a data scientist should also be able to interface with, but it does require a real tech front end. So in particular, there's quite a bit of setup, although there are companies coming out with front ends for that kind of access that data scientists can interface with. For example, usually the Hadoop requires JavaScript, but really they only use Python. Python is a language that data scientists are very comfortable with. So you've got to get to the point where data scientists can write a program in the language they understand and access that Hadoop. And there's also sort of maintenance requirements when you're doing things like Hadoop. So I guess what I'm saying is if you have massive data, then you can still ask a data scientist to go directly into the data, but you're going to need a tech person who's qualified to maintain that connection. So the title of my talk is actually Processes and People, but I'm really going to talk more about people because I just thought of so many things to tell you about the people. And also the people, there's many people here who will be able to talk about the processes and the services on that side. So I'm going to talk now about who and when you should hire and how you should hire. So assuming you have that data set up, like you don't bother hiring a data scientist when you don't have the data set up, but once you have that data access, then how do you go about hiring a data scientist? For example, what are their qualifications? You could just, do you just need a math major? Somebody who majored in math, did a good job at a good school? Do you need a master's in statistics? Or do you need a Ph.D. in machine learning? There are so many different fields from which you can draw a data scientist. And one of the reasons, by the way, is that data science it's not a major yet in school. You can't major in data science. So people end up doing is migrating to data science after they majored in something else. Typically, it's something like statistics, mathematics, physics, computer science. And machine learning is a part of computer science. But I guess my message for this slide is you don't need to be that specific about their field. These are all people that are very, very smart and can learn techniques in data science. So don't focus too much on what exact field they came from. What I do want you to focus on is what they've done and how much they've done. So it really depends on what you're asking them to do in your business. If you're asking them to merely implement a specific strategy that's quantitative, then somebody who's a math major or a master's student might be able to implement something. But if you're asking them to actually design a model that you don't actually even know how to define, you want them to have techniques in their tool belt, and you want them to have creativity and independence. So for that reason, you definitely don't want to have somebody who's just coming out of college as a math major. You need some kind of evidence that they have been able to do independent work. It doesn't have to be a PhD, but it could be. A PhD is typically pretty good evidence that they know how to do something original. A lot of people, though, go into a PhD program and then say, this is just too slow, it's too boring, it's not enough feedback. There's plenty of reasons to leave a PhD program. And depending on what they do after they leave, they could be showing you that they have that kind of necessary independence and originality required. But what I guess the point is that you're not going to have a very specific thing in mind. Oh, I want to see this on the resume in terms of what their exact experience is. But you are going to have to look for real strong signals of very strong raw intelligence and very strong creativity. Those are the two most important things for the data science. What should the job description include? For that reason, you don't want to say, oh, I'm looking for a statistician. Even though you're going to ask the person to do statistics, at least at first, you're not going to say, must have a PhD in statistics. I think that would be too narrow. You probably want to say, must have you could ask for a PhD in a quantitative field or the equivalent job experience. And you can absolutely say things like, you must have demonstrated the ability to do independent work. Then the question becomes, how do you interview somebody like this if you don't already have somebody like this? Because it's difficult to know by talking to someone when they understand mathematics and you don't, or you're not an expert in it, like whether they're full of shit or not. So you definitely want somebody who you can trust to tell you, is this person kosher? Are they really, or are they just spinning a game? I suggest that you could, if you don't have friends that you could bring in to interview someone, that you could actually even hire someone as a consultant to do this. Maybe even two people, because the first person might be themselves full of shit. So yeah, it's a little tricky. It's a little bit tricky. You might also just find a data scientist at another company to borrow them for the day. I mean, there's various ways, but it's definitely worth thinking about. Like, of course, another possibility is that a resume comes in that is absolutely incredible and just demonstrates exactly what you're looking for, and you can talk to people at the old company, and that's another way of doing it. But data scientists are pretty hot right now, so it's possible that you're going to be looking at people that you don't really have a lot of connections to, and you don't know whether their resume is for real. Another thing I wanted to talk about today is, what does a data scientist want from you? Very important for you guys to know what alien race we're talking about. Because I know nerds are mysterious people. They really have different goals. Of course, number one thing is that they want interesting and challenging work, real quantitative questions to ask and answer. If you just say, oh, we need someone to do SQL queries, that's not something that a data scientist is going to, depending on what the SQL queries are going to go towards. If they're just plain, oh, we want to do reporting and we don't know how to do SQL queries to get the numbers out of the database, you're not going to get a very good data scientist. You want it to be a real, you want it at least to potentially be something that they can have a hand in creating interesting questions. So the next absolutely necessary thing to get a good data scientist, to attract a data scientist, you've got to have a lot of data. And remember, we said in order to need a data scientist, you need a lot of data. So this shouldn't be a problem. But I just don't want you to underestimate how sexy data is to a data scientist. Data scientists absolutely slather themselves on data, and they go to bed at night holding and caressing data. It's true. Good data, what's good data? Well, it's clean, it's accessible, so you've done a good job when you're setting up your data access in your database. And it's something that most people don't look at. That's what's especially sexy about data, is if it's new, if you can smell the clean, new data that no one has gotten their hands on, no one's modeled with this data before, and I get to. It's so exciting. Another issue is a lot of these data scientists are, they're leaving whatever they, as I said, data science is not a major, so they're typically like emigrating from something else, maybe academics, maybe finance, maybe a different part of your field. But there's a reason they're coming into business. They want to be part of the business. And you actually want them to be part of the business. You do not want a data scientist somewhere over there sitting next to a finance team. You want this data scientist to be part of your business. And by the end of the slides, hopefully you'll believe me on that one. And of course, if they're joining a startup or a smaller company, they want to be part of the team that's building something. That's like anybody who's wanting to join a startup. They're not doing it because they want to write papers and publish them, right? And if you find somebody who's interviewing who wants to do that, don't hire them. You want to make sure they want to build something with you. Of course, everybody wants a good and ethically sound work atmosphere. And they do want cash money. And I did this in order of importance, in my opinion, which is to say I ended with money. Like, data scientists are nerds. They're not totally obsessed with money. They're much more interested in data than money. Okay, so just keep that in mind. That's what a nerd is like. I've also come up with a bunch of other reasons to hire a data scientist. But before I go into these, are there any questions so far? Okay, as I said, available all day. So one thing, and I talked to my COO about this talk. He suggested that I suggest reporting help as one of the primary reasons to use a data scientist. Now, this can't be, as I said, this can't be the only thing you use a data scientist for, but it is something that data scientists can really help with. Reporting help, what I mean by that is, like, say you have an A/B test going on. I'll talk more about A/B tests. Say you have some tests going on, quantitative test, and you want a report daily, sort of automatically generated, sent to your email in the morning so you can see how the results are going. That could be a pretty big deal and a pretty big tech thing. Like, you would have to tax the tech team by spending a lot of time getting the data and formatting it, and then you might even have to hire a specific person that turns that data from a CSV file or an Excel file into a chart that you can visualize every day. Well, that's not what happens if you have a data scientist. They can generate. This is something I actually generated in about a week. I removed all the labels. But this is just give you a flavor of the kind of thing the data scientists are capable of in pretty short order if they have access to the data. This is done with Python, which is open source, so it's free. On the top left, I'm just estimating revenue of various categories, and then on the left is the sum of all the I break it out by category, and then I take the sum on the left. On the top right, I'm looking at the difference between the two groups, the A group and the B group, the difference in behavior, and see how they buy things differently. And you see those error bars. Those are error bars that decrease over time because we're expecting more data over time. So as time goes on, we're expecting to be collecting more data, so the error bars are going to get tighter. We have a best guess, so we don't expect that to change. Our forecast for the actual difference in behavior of the two groups is constant, but the error bars are changing. So that's the forecast quadrant. Then on the bottom left, we're breaking out the best guesses of the difference of two different groups by category and then in the all. And so you see that you have different kinds of error bars by category. On the right, the error bars are larger because the categories have less data. So it's a very strong relationship between how much data you have and how sure you are of your best guess. And what you see is that on the worst category has pretty large error bars. And of course, what's happily you're seeing here as well is that in the categories that have more data, you actually have closer to a 0 best guess, which is typical. And then you have the all category on the left, which you also have pretty wide error bars on, coming from the categories that have large error bars. And then on the right, I showed the same thing, except instead of in terms of absolute numbers, in terms of dollar units, it's percentage of change. So it takes a little while to learn how to read these graphs, but once I've made one, I can set up a job on my computer to make this every morning with the freshest data that we have and send it to anybody who's interested in seeing this report. So that's a kind of thing that a data scientist can do. This is just a synopsis of what I'm saying. It's enabling you, a data scientist and their tool set enables you to see into your data without taxing the tech team. So they have independent access to the data, and they can show you what you want to see. So data scientists can also help you set up A/B testing. As I mentioned before, if you have, say, an ad to show people, you can split your users into two groups randomly. One will see the ad, one won't see the ad. And if you want to measure the effectiveness of your ad, you look at the difference in their behaviors. And that's what that report was trying to display. There's lots of small, nuanced issues about A/B testing, how to do it right, how to screw it up. Data scientists are supposed to be experts in that, so they'll help you set that up. Data scientists, of course, what they really want to do is something a little more interesting than A/B tests. The way I look at this is, and if you're doing a straightforward A/B test, here's the ad, and here are the users coming up and looking at the ad, and we're trying to sort of forecast their reaction to the ad. But what we'd really like, as data scientists, is to think about it differently. We'd like to take the dual of that, take the people, and bring the ads to them. Forecast which people will react which ways to which ads. So it's adaptability, customization. Look at the people, glean all the information you can from that person, look at their cookies, whatever, infer which ad to show them. Going back to, you see numbers change, you want to know, what does it mean? So let's say your revenue dropped this week. Is that because everything is going down the toilet, or is it a seasonality issue? That's the kind of question that could be really confusing and stressful. But if you have a data scientist, they can look at seasonality issues and correct for them. So you'd say, okay, well, corrected for seasonality, this is your revenue from last week. So you might be able to discern noise from signal that way. And then the next thing that I'm going to go back to at the end, this is a what-if analysis, what I mentioned before, where you have the idea, well, this is, most reporting, going back to the idea of reporting just for a second, most reporting says, here are the numbers today, here's what happened yesterday, here's what happened the previous days. Good reporting has a longitudinal plot of what's been happening up till now for the last few months or whatever into history. But really what you'd like reporting to become is a forecast into the future. So you'd like to know, what are your sensitivities? What would your business profit from the most if something good happened? And what could it possibly suffer from if something bad happened? You might not know that off the top of your head. We'll go back to that. Here's another crucial thing, and this goes back to the idea I was saying before, that you actually want a data scientist to be central to your business. Namely, when you start a new product line, or a new product or a new business, you will probably be asking, as part of the business, part of the stipulation of the business is, I'm going to be measuring such and such and making sure quantitatively this makes sense. But you should, before going ahead and starting that, get your data scientist in the room and say, are we going to have enough data to do that? That's one of the hardest questions that a data scientist comes across because there's a lot of unknowns. So you need a pretty qualified and experienced data scientist to be able to say, well, we're going to estimate, because we've started businesses before, the signal of this will be this, yay strong, and this is how much data we're going to need to be able to measure that signal. And similarly, oftentimes you're actually trying to optimize on something. You're saying, we'll start out this way, but as we get information, we're going to increase coverage and decrease risk mitigation in the following way. And that's an optimization problem, which again, you need to have a lot of data typically to be able to actually do that successfully. So you should be asking your data scientist, as you plan the business, are we going to have enough data for this? Next thing is, data scientists should be able to educate and communicate all these things to senior management. So for that reason, and I didn't stress this enough when I was talking about what you should be looking for in qualifications, you absolutely need to be looking for a good communicator. Your data scientist, at least the lead data scientist, should absolutely be someone who, if they can't explain what a confidence interval is to you in the interview, then don't hire them. So actually, you don't just hire consultants to interview data scientists. You should also go into the room, talk to the data scientist, make sure they speak well, speak clearly, and they teach you something every time you ask them a question. Not to say that they have to have everything at the tip of their fingers, but given them enough time, they absolutely should be able to explain almost anything to you. And to your clients. And this is a very key point. Sometimes you might need to explain a particularly difficult thing to your client. You might say, you know what, I'm going to bring my data scientist in here to explain this to you. And that's perfectly valid. So you want to make sure you're hiring someone who's capable of giving presentations and communicating. So I wanted to end my presentation with a case study on stress tests. So this is this is like the what-if analysis I mentioned before. And the first thing I want to say about it is that I stole it from finance. I was in finance. I worked at a hedge fund for a couple years, and I worked at a risk software company. We did portfolio risk analysis overnight for hedge funds and banks. And we take a hedge fund, we take a portfolio, maybe massive, probably massive, and we would see what would happen if the markets moved. So we take that portfolio and sort of like the way we think about it is to simulate a day in the market, or maybe even longer, maybe a week in the market, and see what would happen to that portfolio under those conditions. And all sorts of things could happen. We let our clients specify the scenarios to test. Sometimes we did historical tests, like we said, well, replay the credit crisis on this portfolio. What would happen if that happened again right now to my portfolio? What kind of losses could I see? Or just change the interest rate. Say the Fed just makes a surprise announcement, changes the interest rate. So all sorts of things could happen. These are scenarios, and that's what we've done. That's what I'm going to do that in the realm of marketing, internet marketing. But before I do, I just wanted to mention, I have a little thing about data miners being spoiled for data. Like, we all love data. I mentioned that before. But people coming from finance, this might surprise you to hear, but they don't have as much data as people in the internet industries. People in the internet industries have massive amounts of data. It's like they're so spoiled. It's great. I'm one of them now. I'm very happy to be. But the good thing about people from finance is that we have the quants had discipline in the sense that we never had enough data. So we had to sort of squeeze the juice out of every time series that we did have. And for that reason, stealing methods from finance is probably a pretty good plan. Although, obviously, if you have way more data, you can do way more. So let me just say it this way. If you have room for 3 data scientists on your team, try to get one from finance, try to get one from data mining, and mix it up a little bit because the techniques are very different. Depending on your data set, they're going to be really good at various different things. So going back to the point of the stress tests is, if I'm going to put it in the setup of the realm that I work in, which is that I have a company, we hold a platform for advertisers. So we maybe have like 15 advertisers that are in an auction, much like a Google Ads auction. And we know, of course, that if one of them drops out of especially if it's an advertiser with a high bid, then it's going to be bad for us. It's going to be bad for our revenue. On the other hand, it's going to be good for some of the other advertisers. So, how do we measure, and that matters, of course. It also matters if they raise or lower their bid, and they want to know how much it matters. They want to optimize their bid. So here's a picture. Oh, sorry, I'm one slide ahead. So the whole point of stress tests is that it's just like what I said we did with portfolios. We're going to allow, in a given stress test, for you to adjust one or more things at the same time. So you could say, advertiser 1 brings up their bid by 50%. What happens? And you can look at it from various perspectives. What happens to them? What happens to other advertisers? And what happens to my bottom line in various ways? What's my click-through rate? What's my fill rate? What's my revenue? And I've just drawn a picture. This is my final slide of just a very simple stress test. This is the kind of visual that you might get. And I'll explain it. So we have 15 advertisers in this auction. In fact, we have 15 advertisers in all auctions, let's say. And this is just asking if the x-axis below is showing you the delta change in the bid for the various advertisers. So advertiser 13 could raise their bids up by 50% or lower their bids down by 50%. And the question is, how would their impression share change for them? That's what I'm modeling right here. But as I said, you could do this in various ways. So going back to advertiser 13, you see that if they raise their bid 50%, they're raising their imp share by 75%, approximately. We could actually show numbers here if you wanted to. Versus advertiser 12, which if they lowered their bid by 50%, they'd really lose out on a lot of impression share. Now, this is a useful chart for someone who deals with clients, the advertiser clients. If I give them this chart and they're on the phone with one of these advertisers, they could just talk to that advertiser directly about what they're looking at here. This is just, the way I did this was in finance, when we did the stress test, we used all the data, all the time series of the past that are related to the things in the portfolio. Here, I just took the last 2 weeks of the actual auctions and bids and traffic, and I just replayed it under different conditions with using synthetic auctions and various proxies for quality scores. But that's the kind of thing the data scientists can do. That's sort of my point. You can actually see a quantitative forecast for your business under various scenarios. I'm going to stop right there. Thank you very much, and I'll take questions.
I have a couple of questions for you. Sure. And I'm going to defer to you guys if you raise your hands. This chart looks like kind of, Tetris for mathematicians, but I could see if I was a salesperson trying to figure out how to bid on a contract and it was a closed bid, if I had this kind of stuff, I could presumably get a best estimate of what I should bid on that contract, which is something that's been done for multi-million-dollar RFPs, but very seldom for I'm going to sell you a router. Do you see this stuff getting into the hands of mortals for, like, now the barrier to entry is down? Is this going to affect, how's it going to really affect the mortal in the middle of the organization to have access to these tools?
I mean, that's exactly why I built it. I built it for the client-facing people and for the people in charge of making sure that the revenue is coming in well. So, but for basically two different groups of people. But it's specifically targeted at the people who are trying to talk up the clients. You should really not lower your bid because here's what would happen if you did. So that's exactly the goal of it.
So what other areas of the business do you see this kind of stuff having the most impact? Where's the low-hanging fruit for a business to bring in a data scientist?
Well, I tried to show a couple of different ways, the reporting and the kind of stress tests. But actually, probably the most useful one is the IP that I'm not allowed to talk about,
right?
Which is this idea of, like, as I only mentioned it tangentially when I said you want to look at the consumer coming in and use all the data you can from them to know what to show them. I think that's real data mining, that's real forecasting, and that's probably the number one way you're going to use a data miner to improve your business, is something in that order.
Is there a particular, let's say you walk around the office and you got the VP of HR and the VP of Finance and the VP of Sales, whose office is going to change the most because of the democratization of big data?
Wow. I mean, all of them. I mean, that's the thing. Maybe finance is a little bit more backwards looking than forwards looking. So I'd say sales would definitely be jumping on it. Because this is the whole point of data mining and data science is forward looking. What can we do next?
Yeah, I've been seeing a lot of people who are asking how we can do analytics for ad buys and clicks and visits because everything you do is measurable and tracked. Mm-hmm. But these days, if you're doing a sales call, you could sort of do sentiment analysis on someone's Twitter feed and how their stock price is doing and whether they're in the office today and how many meetings they've scheduled that they've talked about recently, and assess who's the best prospect to call on a given day based on that kind of data.
It's exactly the kind of thing you should do.
And that's getting really
as long as
spooky.
You can collect that
right.
data. So number one thing is collect the best, sexiest data you can.
And according to Nolan, whether you're allowed to use it, right?
What's that?
According to Nolan, whether you're allowed to actually use that data, you may know it, but yes. It's illegal, right?
Yes. That's not my expertise. Yeah. I use all the data that is given to me.
Thank you very much, Cathy.
Thank you.